Hello everyone, welcome to today's class. Today's class is all about Kubernetes. Let's first talk about what is Kubernetes. Kubernetes is a container orchestration tool like Docker Swarm. It helps us to scale containers, do auto scaling, load balancing, high availability, all those things. One thing to note, using Kubernetes, we cannot create images. There's a big confusion. To create images, you use Docker, but to do orchestration, like we do in Docker Swarm, we use Kubernetes. Docker Swarm is a product of Docker, while Kubernetes is a product of Google, which is now managed by Cloud Native Foundation. What is the difference between then Docker Swarm and Kubernetes? If using both the tools, I can achieve high availability, load balancing, auto scaling, all those things, then how do you both compare neck to neck? So now in Docker Swarm, you can only do container orchestrations for containers created using Docker as your solution. That means I have created images using Docker as my container solution, then only I can use Docker Swarm for container orchestration. But Docker is not the only tool in the market for container orchestration. There are a lot of other products as we discussed, like LXC, Rocket, CLI, all those things. If you have created your images with any of the container solutions, Kubernetes works on all of them. There is no limitation with Kubernetes. Second biggest drawback of Docker Swarm is there is no provision of auto scaling, which is one of the most important necessity in any corporate requirement. You don't want an engineer sitting manually and scaling servers now and then based on the requirement. You want to set up some condition. Let's say Sridhar wants to set up a condition. If the CPU utilization on my current existing containers goes beyond 60%, spin up two more containers. Or if CPU utilization goes below 10%, then destroy one of the containers. All those things in an automated manner can be easily done using Kubernetes, which is not possible using Docker Swarm. Now, talking about Kubernetes architecture, Kubernetes follows a master node architecture, or you can say a master slave architecture, where you have got one master and multiple number of or n number of Kubernetes nodes connected to it. Let's talk about Kubernetes master architecture. So master is the control plane of entire Kubernetes cluster, or you can say all the major decisions are made here and the works are carried out by the Kubernetes. So now in the master architecture, as you can see in the diagram, which I have shared in the Slack channel also, there are many important components like API server, controller manager, scheduler, and etcd. Let's talk in detail about each of these components in the Kubernetes master architecture. Let's start with API server. API server is called the front end component of Kubernetes master. When I say front end component, what do we mean by this? So when you create this cluster, you define the configuration in a file called manifest file. This manifest file can either be created in YAML or JSON. It accepts both YAML and JSON, as you can say, the programming language for creating Kubernetes manifest file. In Kubernetes, we follow a declarative approach. So what does declarative approach means is that you put all your instructions inside that YAML file or the manifest file that you're creating. So when I create that manifest file and when I try to run it, in backend what happens is it tries to feed every data or every information to this API server component. That is why it is called the front end component, because whenever you run the manifest file, the first component it interacts with or it feeds the data is called as the API server. This API server performs another major job in the Kubernetes architecture. It does an evaluation. Basically, it validates the manifest file and tries to see if the syntax or the format you are using is correct or not. That is what the job of API server is. Once API server receives that manifest file, evaluates it, then it talks to the nodes to deploy that particular job. That is the job of API server. Before API server go ahead and perform that task on the Kubernetes node, it needs to interact with other components of the Kubernetes master architecture also. The first component it interacts is called as etcd. What is etcd? Etcd is a very common component. You use it in all databases, everything. It's a very common thing. What is etcd? Etcd is like the cluster store or memory. You can say it acts like a NoSQL database. All your cluster information is stored in the etcd components. Here, all the values in the Kubernetes architecture are stored in the form of key value pair. That is the role of etcd. So in short, it is the memory database of the entire Kubernetes architecture. Now the next component is controller manager. So what this controller manager does it, It verifies whether the desired state of my cluster is equal to the actual state. Now, what is desired state and what is actual state? Let's say Shri wants to scale up his containers, and Shri wants to have 8 nodes, or you can say 8 containers for his application, the scalability he is looking for, or the scale up. Now, 8 is the desired state. The Shri wants to have 8 containers, but how to make sure these 8 are achieved in actual? So this often you have seen a Docker swarm also. We used to get value like 3 bar 3 or 4 bar 4. The right side of the value indicates the desired state, how much you are looking for. The left side indicates how much is the actual state. In Kubernetes architecture, it is the job of controller manager to make sure your desired state is equal to the actual state. Now, say for example, for some reason, your desired state is not equal to the actual state. So it's the responsibility of controller manager to run in some loops in parallel in backend and make sure your desired state is equal to the actual state. That is what the job of controller manager is. In Kubernetes, we define our desired state in YAML file, or you can say the manifest file that we create. Now, the last important component of Kubernetes master architecture, scheduler. So as the name implies, scheduler job is to delegate the work on different Kubernetes nodes. This scheduler components plays a very vital part. Now, let's say, for example, I've got 5 nodes at a time linked to one of my Kubernetes master. How do master make a decision on which particular Kubernetes node I need to deploy a specific container or run some services? All those decisions are taken care by the scheduler component. A scheduler component weights a lot of parameters like currently available resources, currently running resources, used parameters, and on base of those criteria, it makes a decision on what particular nodes those particular clusters need to be executed. That is the job of scheduler component. Now let's talk about Kubernetes node architecture. Kubernetes node architecture has got different important components like kubelet, cAdvisor, kubeproxy, pod, and some plugin networks. We'll talk about this. First, let's talk about kubelet. Kubelet is a major component of Kubernetes node architecture. As you can see from the diagram, is to interact with the API server or the front-end component of Kubernetes master, get the information and deploy the information into the Kubernetes node. That is the job of kubelet. Second component let's talk about is kubeproxy. So kubeproxy basically is a networking component. It takes care of networking concept between a user and a container. So means if we have an application running in container which need to be accessed by the outside world or by the end user, kubeproxy will take care of it. You can compare it something like port forwarding or binding port of the Docker world. This kubeproxy takes care of the networking concept between the user and container. The next component is cAdvisor. cAdvisor is nothing, it's a runtime advisor for your Kubernetes architecture. Now, as I told you guys, Kubernetes can manage containers of any type, whether Docker, Rocket, OCI, LXC, call, and any others. How does Kubernetes know that you have created the container using a specific type of container solution like Docker? That particular piece of job is handled by cAdvisor. It is nothing but you can say it's your runtime environment. So for example, in this scenario, we are going to run Kubernetes using Docker as the container solution. So cAdvisor will make sure that before we run some Kubernetes command, Docker is present on those machines and up and running. That is the job of cAdvisor. It is your runtime solution for your Kubernetes architecture. Pod is the most important thing in a Kubernetes cluster. In Kubernetes cluster, we don't run containers directly. Every container is present inside the pod. So you can say pod is a layer above container. So for example, if you want to create a container in a Kubernetes architecture, you cannot create the container directly. Containers are always present inside the pod. If this square, for example, let's say this is the pod, then inside the pod only you can have containers. Containers are not present openly or freely like we have in the Docker architecture. Pod is a layer above containers. Pod creates or provides the runtime environments for containers. Containers will always be enclosed inside the pod in a Kubernetes architecture. You can say it provides a layer of abstraction. On those lines, we remember in Docker or Docker Swarm architecture, container used to have their own IP address, own networking, right? But in Kubernetes architecture, containers don't have its own IP or own networking. Container shares the IP networking details of the pod inside which they are present. So for example, in this scenario, if this is my pod, for example, then the container present inside this pod will not have its own IP address. It will share the IP address and networking details of the pod inside which it is present. In general, we have one container per pod. So for example, if I want to access this container, so how I can access this container? Using the pod IP address colon pod port number, because here containers don't have its own IP address or own networking details. They share the IP address and networking details of the pod inside which they are present. Kubernetes has got one very big problem. The problem with Kubernetes is Kubernetes installation is not uniform. When I say uniform, what I mean by that is Kubernetes installation varies from environment to environment. How I install Kubernetes in Google Cloud is completely different from how you're going to install Kubernetes in Azure Cloud or AWS Cloud or some other OpenShift environment. Let's create a VM from scratch. Nothing is installed. I'm going to create a fresh VM so that everything we look from scratch. Nothing we believe that's been already installed or open code. Let's say Kubernetes. I don't want a heavy machine. Now guys, in Kubernetes architecture, we use a command line utility tool called 𝐂𝐝CTL. Kubernetes control, if I abbreviate it. So first thing I will do is I will install 𝐂𝐶TL as my command line tool for the Kubernetes architecture. So how to install? Simple yum install -y 𝐂𝐶TL. Another thing is, since I am using Google Cloud, whenever I create a Kubernetes architecture, I need to link it to some project. So let me copy a project ID. So every time you create an account in Google Cloud, you would see something like my first project, or you can create your own project. So let me copy this project ID. So what is happening is I'm telling Google Cloud that the Kubernetes cluster I'm going to create is going to link to this project called my first project. Basically, I'm telling it to link Kubernetes architecture to specific project. See, if I tell you in terms of Azure, I don't know AWS, it is like linking your Kubernetes cluster to specific subscription. So now let me link that particular Kubernetes cluster to this project. For that, we use a keyword in Kubernetes architecture called export. We define which project ID I want to export it. So let me go back to terminal. Let me run the command export project underscore ID and give whatever your project ID is. So it will have unique project ID. No two users will have the same project ID. So for example, let's say we are 18 participants. None of the two participants will share the same project ID. Project ID is unique for everyone globally. So now I'm exporting this project ID, which we just now copied from our Google Cloud instance, and we are putting it there. Now third, we have to initialize Google Cloud. For that, we use a command called 𝐸Cloud_init, Google Cloud initialized. So let's press enter. It will ask for tons of questions once we initialize Google Cloud. Let's press enter. First, it's asking you how you would like to perform this operation. You want to use a default account or to log in with a new account. Let's say I want to use a default account. Enter the project ID you would like to use. Okay. So let's copy that project ID again. Let me go back to Google Cloud. Let's copy this. Let's try to create a new account. It is not liking this. Create a new configuration. Enter configuration name. Let's say kushaag-kubernetes 1, 2. You want to use or log in with the new account, put login with the new account. Yes. So now copy this Google account ID. Okay, it's like authentication that whoever is running this account is a genuine person. Copy this, go to your browser, paste it. It will ask you which particular account you want to authenticate it again. So let's say I want to authenticate using some Google account. Click on allow, copy this particular code and paste it there. Now, which cloud project you want to use? I want to use the first one, articulate bot, let's say. Do you want to configure region globally, in which region your Kubernetes cluster should run? Just say yes. Now, this is the most tricky part. Why I say tricky is, right now I'm using a free account. With free account, most of the time, Kubernetes installation fails at times. We're not using a paid Google account, right? So let's take an account and hopefully let's hope it will not fail. Let's say I will use to create this account in Asia South 1, for example. Let's use 35 and let's see what happens. So now this went fine. Now let's create a Kubernetes cluster. See here, it's the same project we select, my first project, the project we exported. Let's create our Kubernetes cluster. It can be any project. That's very, very true. It can be a microservice project. It can be your own project, sort of a project tied to your current work. It can be anything. You can create your own project and link it to that. I know Kubernetes installation is tricky. Firstly, I don't believe 3 hours is the right time to teach Kubernetes. Since a part of the course, I have to do the justice with it. I'm going to create a cluster, 𝐸Cloud containers cluster create, and the name of your cluster that you want to create. For example, I gave my cluster name as cluster1. You can give whatever name you want. It just need to be in lowercase. Now guys, it is showing something is going to happen. What happens is, guys, in free account, Google allows maximum 8 resources to be created. Let me see how many resources I'm having. I'm having 5 resources, right? It should work. Let me delete one more VM, guys. I don't know why it is not allowing. Let me delete one more VM. I don't have any resources. Why it is behaving this way? Magic of free account, guys. So what happens is, in a free account at a time you can have maximum 8 resources in Google account. Now I have only 4, so I have still 4 resources available. So let's see if it works now. Okay, response code 0, insufficient regional quota. Oh, okay. So let me reinitialize and put some other region. See, insufficient regional quota satisfied the request resource CPUs. Request requires 3 and is short. The project has a quota of 002 with 00 available. View and manage quotas here. So what is happening is, I gave some reason, right? That particular region don't have that much quota to basically spin up my resource. So I need to again reinitialize, give some other region. Biggest problem with these free accounts, right? That you don't have these quotas to spin up resources or do things. Let me see what is my quota of that region and I can change that. Okay, let's do one thing. The cluster is being deleted. I will give some other name. So let's give some other name. Let's say cluster2. You see, cluster is getting created. Apologize for the delay. So now if I go back and go to the Google Cloud, here if I see and I refresh, I should see a cluster2 getting deployed. It takes a while, probably take 2-3 minutes for the entire cluster to be deployed. So it's deploying a cluster in the Asia Northeast region with 3 nodes. Okay, if you want to validate, go to your main machine, click on this compute engine and click on VM instances. 3 new VMs will be getting created as part of your Kubernetes architecture initialization. See here, these are going to act as your Kubernetes cluster. Give it a while for the entire setup to complete. First time when we try to initialize, we are given a different region. We gave some region called, I think 35, we gave Asia South 1C. So we gave a cluster 1, it tried to spin up and it blocked those 3 resources. And we went out of resources because maximum you can have 8 resources in free account. And that region did not have 3 resources to permit. So there was soft lock happen. So we removed that cluster, changed the region, again initialized, now it's working. Simple as that. One of the biggest thing in running Kubernetes in any environment, whether Google, AWS, Azure, it's very cost intensive. If I run this for 3 hours, it is going to roughly cost me, if I'm not wrong, around $7, $7 US. I think $2.3 per hour, something it is. So it's very expensive to run in a free account also. That means in 3 hours, I will almost burn up my 600 Indian rupees of credit. See, Amrish, Kubernetes is never meant for your bare metal machines. People use it by doing some workaround. It is not supposed to be that way. Kubernetes was designed for cloud management only. It was never designed for your hardcore Linux environment. So let's validate Kubernetes got successfully installed or not. First command, we installed 𝐂𝐝CTL. Remember the command and utility 𝐂𝐝CTL get nodes. Come on, see, we have 3 nodes which got connected as part of this Kubernetes cluster. First thing, I just wanted to make sure Kubernetes is running. 3 VMs are connected to it. I am getting that. Okay. Let's see Kubernetes version. I think the command is 𝐂𝐝CTL version. So let's see -- short. See, I'm running Kubernetes client version 1.18. Don't worry about server version. That is not important. We are running Kubernetes version 1.18.8. Now, if you remember, I told you a while back in Kubernetes, we don't create containers directly. We create pods and containers are present inside the pod. Now, how do I create a pod and put a container inside that pod? Everything will use using command line tool called 𝐂𝐝CTL. That is a command line utility. Let's say you want to create a pod named pod1. And let's say inside the pod, you want to create a container which use nginx image. So I'm using command 𝐂𝐝CTL run pod1. I have to create a pod called pod1. Inside the pod1, we should have a container called which is using a nginx image. So I got a message pod/pod1 created. How do I validate? So the command for that is 𝐂𝐝CTL get pods -o_wide. Okay, -o_wide means it will show all the proper fields for the particular pod. See, I got a pod named pod1 created. See, 1/1. We want to create one pod, and inside one pod actually got created. Status is running. It got created before 17 seconds before. This is its IP address 10.52.2.5. It is running on this node G919. That is how you can see how many pods are created. So now if you want to see more information, so let's say 𝐂𝐝CTL describe pod1. So describe, you can say something like inspect. You remember in Docker world, we use a command called inspect to see anything about containers and images. Same in Kubernetes world, we use a word called describe. So if I run enter, I will see all the details about this particular pod. What container is running inside the pod. See, this pod is running. See, this is the pod first. Inside the pod, you're running a container. This is my container ID. This particular container is using Nginx image. This image is pulled from Docker. It first create a container, it first create a pod. Inside the pod, we are seeing a container ID, which has been created using this particular image called Nginx. Same way, you can see all the details like IP address. Here I told you IP address, the IP address of the pod. You don't see IP address of the container because containers don't have their own IP address. Containers share the IP address of the pod inside which they are present. Do you see anywhere in this entire details we are seeing anywhere container IP address? If I compare to Docker or Docker Swarm world, whenever I used to run Docker inspect or Docker network something, I used to see containers IPs and container networking. Here in Kubernetes, you will see pod IPs and pod networking. You will never see the details of the container IPs of container networking because containers don't have their own IP address. Containers share the IP address of the pod inside which they are present. Now, if you want to go inside the pod and do something, for that we use a command called kubectl, same like Docker, exec -it, the name of your pod, that is pod1. And how you want to log in, let's say I want to log in as bash mode, that is space bash. See, now I am inside pod1. That is how you go inside a pod. I press command button in Mac, control P and Q. Once you press control P and Q, it will come out of your pod. I think I did not did a good job in coming out. Let me do kubectl get pod. Is it running or stopped? I came out successfully. See, so now if you want to come out of your pod, the command is control P and Q. Same like Docker world. Now let's say you want to delete this pod. So the command for that is kubectl delete pod and give the pod name. Let's say pod1. And if I give to get pods, now there is no pod. In general, as I told you, let's go back to Kubernetes architecture. We used to create a manifest file that is either created in YAML or JSON to create pods. So far, we are creating pods using some one-liner command. Let's say kubectl run pod using Nginx or Tomcat or Apache, whatever you want. Let's say you want to see a YAML file on how to create a pod. So if I run this command, kubectl run pod1 -- image, let's say Nginx, in backend what it is doing is it's creating a YAML file and feeding that YAML file to their API server component or the front-end component Kubernetes master. Now, how does that YAML file look like? I can convert that into YAML file here itself. You have to use a flag called --dry -run equals to client -o YAML. So what you're telling is when you are running this particular command, do a dry run and convert this particular command execution syntax into a YAML. See, when I'm running a command, basically it is running a YAML file of this sort. When I'm trying to create a pod with a container, what it is doing is it is running a YAML file which is picking these configuration by default. One more point to note here, that's why I run this. In this command, use a flag called dry run. So dry run means actual execution is not happening. You are just checking if I run this command, what will happen. If you want to run the command actually and want to actually create the pod, for that, remove this dry run flag from there. That way, pod will get created. Dry run is, I hope all of you have went to the DevOps class where you would have learned Ansible. And Ansible will do something called diff check. It is a diff check for Kubernetes. It's like a testing. You're not actually rolling out. You're trying to check if I roll out, what will happen. Let's say right now, I made this pod called pod1. This pod is up and running. You see the status running. And we know if I run this pod, it is using some image called Nginx. Let's say you want to change the image. You want to edit the pod of it. For that, use a command called kubectl edit pod and then the name of your pod. Let's say you want to edit pod1. What you can do is you can change the image. For example, see, right now it was using Nginx image. I can change Nginx to Apache. Let me put httpd and let me save this file. In the previous scenario, when I run kubectl get pods without doing edit, I was showing restarts at 0. Now let me run the same command again, kubectl get pods. I see restarts as 1. Can anyone explain me why does the pod got restarted? See, previously when I use the original file Nginx image, it was showing 0 restarts. Now when I made some change, it is showing 1 restart. So now in order to change this to reflect, we are showing this thing restarts as 1. If you want to double check, you guys don't believe me, let's use the word kubectl describe pod and then the name of our pod. See here, now this container is using the Apache. It is no more. So this is another big advantage of using Kubernetes. You cannot do this so smoothly in Docker or Docker Swarm world. We can do this so smoothly in a Kubernetes world. Now Kubernetes architecture is slightly more complicated. Now what are these high level objects and how do we use them? In Kubernetes, by default, you don't get things like high availability or load balancing or scaling. In order to achieve those things, we use some high level objects. These high level objects sits on top of your pod. So for example, if I want to do something, let's say as scaling, then I will use a high level object called deployment. Using this high level object, I can do scaling in my Kubernetes architecture. So now we are going to see how to use high level objects and achieve things like high availability, load balancing, auto scaling in a Kubernetes architecture. So some of the most commonly used high level objects are replication, replica set, deployment, service. These are some of the most commonly used high level objects used in Kubernetes architecture. Again, I will use in Kubernetes architecture, by default, you cannot achieve things like load balancing or scaling or auto scaling. Okay. In order to achieve these things, we need to use some high level objects. Now I'm going to show you how to use these high level objects in order to achieve these goals. So now guys, I'm going to show you to use a high level object called deployment. Let's give it some name. Let's say vi dep.yaml. It's all in YAML file. I want everyone to take a minute and try to understand what we are going to do with this particular YAML file. And then I will explain you what these different fields mean here in this particular YAML file. Deployment, as I told you, it's a high level object that sits on top of your pod. So now in this particular YAML file, you see the first field as API version. So API version and kinds are called headers in a Kubernetes YAML file. These are the mandatory fields you need to define or create whenever you're creating a Kubernetes manifest file. There are different API versions available like V1, V1 beta, app extension. So here for deployment, you have to use API version as apps V1. These are something called predefined by the Kubernetes community and to use accordingly. Now another field is called kind. The default kind is called as pod. Okay, but if you're not defining any kind, the default takes as pod. But if you're using any high level object like deployment service, you need to define that particular kind. So for example, I'm using a high level object called deployment. So I'm defining kind as deployment. Then you have another field called metadata. What is about? Your information about your pod, like its name, identifier, something which helps to identify your pod, that is called as metadata. Then you have another thing called labels. Labels are identifier for your pod. Let's say you want to define which application my particular pods belongs to, or let's say which environment is running. Let's say prod, dev, QA. Those all things we define inside labels. Labels are very powerful, guys, and very important. Another thing that you see here is called as replicas. That means how many replicas you want to create for your container. For example, here I want to create 3 replicas for my container. That means 3 pods should get created, and inside these 3 pods I should have 3 containers. Then again you define something called container. That means what is the name of the container you want to give, and from which particular image this container should get created. Then something called container port, that is internally what is the default port for application. This is not the external port, it is the internal port that you want to create for application, that we call as container port. So that is how, guys, we define a typical YAML file in a Kubernetes architecture. If you remember, as part of this dep.yaml, we made 3 pods. If I delete any one of these pods, what do you think will happen? Will it respin one more pod, or will that pod will remain in the same state? So let's say as part of the service deployment, which name is my deployment, I made these 3 pods, right? Let's say I delete one of the pods. What will happen? It will respin or it will just die. Let's see what will happen. So let me delete one of these pods. So kubectl delete pod and this pod name. Okay, I got it. So let me delete this pod slash. So I'm deleting this pod now. This pod got deleted. Now see the magic. If I run the command 𝐂𝐞𝐫𝐞, you see I will still see 3 pods running. This is what is called as auto healing. It auto heals itself, because I told you while discussing the architecture, we have a component called controller manager, whose job is to make sure your desired state is equal to the actual state. So now controller manager knows my desired state is 3, which we define in our manifest file. So it will make sure that actually we are getting those 3 pods. Let me show you one more command. We can use this command if you want to see what all labels are being used for your pods. You can use the command kubectl get pods dash dash show dash labels. So see, these are the pods getting created and these are the labels for it. App equal to my app, okay, and this is running pod one, the default label. Now if you want to list all the pods with this app equal to this particular thing, my app only, you can use a command kubectl get pods, I think dash lowercase if I'm not wrong, app equal to my app. So now it will list all the pods which are using this particular label, app equal to my app. That is how you can list your pods with the specific labels here. Now let's say all these pods, we remember, got created as part of one specific deployment, right? I think I gave the deployment name as my deployment. Let me just get the deployment name. It's my deployment, right? If you want to see all the details about this deployment, this high level object, the command you can use it kubectl describe deploy and then the deployment high level object name, my deployment. It will tell you all the details about your this high level object. See here, 3 desired, 3 total, 3 available. That is, you can see your application strategy here. You can see what is the IP it is using, on what all host it is running, different nodes of your architecture. Everything you can find out with this describe command. This basically tells you all the information. Now I will show you another beautiful thing about Kubernetes. Okay, this was all the CLI thing. Let me show you some GUI thing about Kubernetes. What if I tell you to install Kubernetes cluster? I no need to do all that hard work. I can install the click of a button. What if I tell you can create directly without doing all this anki fanky? How to do that? Please pay attention. Click on this hamburger sign on your left. Go to Kubernetes engine. Go to clusters. Okay. Click on create cluster. Give your cluster name, which zone you want to run it, or which region you want to run it. Okay. You have to define this. Which particular version you want to use, a static version or release version. Release version is something which, like if you have something version in testing environment, something being deployed, rolled out, that comes as release version. Static version means the current version which is universally accepted or a stable version, and just click on create. Your Kubernetes cluster will be created. It's as easy as that. See right now the beauty here is how do I monitor my Kubernetes engine using the GUI or using graphical user interface. Firstly, make sure you are in the correct project where you installed Kubernetes. For example, I am running Kubernetes in my first project, so I'm in the correct project. If I give my project 31007, I cannot get all details about my Kubernetes cluster. Now you see in my Kubernetes cluster right now, 4 pods are running. I can see here, one is my deployment and one is pod 1. In pod 1, we are running only 1 pod. In my deployment, we are running 3 pods. Click on my deployment. You will find details about your pod, how much CPU they are using, how much memory they are using, details about it, like what the app, what label they are using, what is the current state this having. Then if you want to find any changes made, that means you did some kubectl edit, that is what we call as revision history. Then you want to find any events. Events are linked to a revision history mainly. When you make any change, it links as a new event. Then what is a raw YAML file? Let's say I created this pod and tomorrow I left my company. I want to see what YAML was used to create this pod. All those details you can find in the front end here about your Kubernetes pod. Whichever pod you want to do, you can find those details here. Same way here, we can do an auto scaling from the GUI itself here. Click on this action tab and select the option auto scale. Here you can do auto scaling on based of lot of criteria like CPU, memory. You can give some custom metrics, or you can pass some external metrics. You can specify some the value. If my value goes above 80%, then do an auto scale. How much auto scale you want to do? That means minimum is 3, and you're going to give maximum is 10, 20. That way your auto scaling will happen in an automatic manner. That is how we enable auto scaling in a Kubernetes architecture. This was the first part where we see how to create some scale sets basically. Now comes the second part. How do we expose this particular pod to the outside world? Let's talk about the second thing, the second high level object which is often used. So far we use the first high level object called describe. Now we have another high level object called service. Now we are going to see how to use high level object called service. The good thing is, to use this high level object service, I no need to create a YAML file directly. I can do a high level object service using some basic commands. Let me create a new pod. Okay, so let's say kubectl run pod2, let's say pod2 dash dash image http. Now if I do kubectl get pods, we have this http pod2 getting created. Let's give a minute. Now it is up and running. Let's say I want to expose this pod2 to outside world. How do I do that? Use a command called kubectl expose. What particular pod you want to expose? Let's say I want to expose pod2. Now give some name to it. Let's say name push, whatever name you want to give. Then which particular port you want to expose to. So dash dash port, I want to expose to port 80, for example. And the type we use is, for example, if you remember, in Docker we used to do something called port forwarding and binding port. Here we use a word called node port. So define dash dash type node port. You can compare this something called like lowercase p. We used to give dash some uppercase p, lowercase p. So here we don't give lowercase uppercase p. Instead define here dash dash type as node port. And now let's press enter. So you see we got a message service slash push exposed. Let's double check. Don't believe me. Run a command kubectl get svc. See why svc? Because the high level object name here is service. That's why I'm using svc. Press enter. So if you see here, I made a high level object called service called push. And you see it's using port 80:31311, something it is coming up. This is the internal IP, cluster IP. I want to validate whether outside world can access it. Let's take IP address of one of the nodes which get created as part of Kubernetes installation. So let's go here, compute engine VM instances. Let's copy this. And what was the port number? Second, guys, I don't remember the port number. 31311. See here, that's how we can expose any application we create. 313 is a port number. It's like you can say binding port, automatically assign a port number on which your application can be exposed to outside. Now let's say if you want to see YAML file, how will the YAML file looks like? Okay, I will use the same thing and I will just put something called, as discussed, dash dash dry run. I don't want to create it again, equal to client dash o YAML. See, this is how your port forwarding looks like in form of a YAML file syntax. See, API version kind, I told you they are your header fields. Then your metadata, your specs, you're creating a pod with the name pod2. Your name for your service is push. Internal port is 80. You're exposing the port as port 80. You're targeting port 2 and using type as node. That is how your YAML file looks like. Let's say I want to combine both these scenarios. I want to create one single YAML file where I can do some scale up, scale down, means scaling basically, and same time I can expose that application to outside world. For that, guys, we can do that also in one YAML file. Okay, so let me put this YAML file in this particular as a file, and then we'll discuss. 1 second. Vi, let's say a.yaml escape cert control V. Okay, so guys, I hope everyone can see my screen. I've added some more flags to this field. We'll talk about it. See, first two fields, API version kind, we already discussed. First two fields, API version and kind, we already discussed. First I'm using for creating a scaling up. I just called a coin called deployment, where I gave some name called 𝐂𝐝, and I gave replica as 8. That means I want to create 8 replicas. Then I gave 9 min ready seconds, another flag called 45 seconds. That means it waits for 45 seconds before pod is ready and going to the next pod. This is a new flag I introduced. So you want your pod to wait for a specific time before switching over to next pod. You can use a flag called min ready seconds. Then let's say you want to do a roll update. So for example, I'm creating this pod using this particular image, lead DevOps 𝐶-𝐻 right? This is the image being used to create this particular pod. Now tomorrow I changes the image using kubectl edit as we discussed, and I gave some image name from lead DevOps to say Nginx. Then I gave a condition that at a time take down only one pod. Don't take down all the 8 pods at one go, only take down one pod. And once that pod is done, then only move to other pod. For that, we can use a speed flag called max unavailable. Then there's another flag called max search. If a deployment is run, pick maximum 2 pods at a time and do update of 1 pod at a time. That is the field we call as max search. This is another field we can use, or a flag in the Kubernetes installation. Now this is how my high level object deployment is being done. Now I want to expose it to outside world. Here I'm using service. I'm exposing it on port 80 using type as node. That is how I'm combining both the high level objects or 2 YAML files in one go. API with deployment and service. Let's save it for now. Let's run this file. Again, how to run it? kubectl create -f and the name of the file a.yaml, whatever it is. Let's run the command kubectl get all to see what all resources got created. See, Right now, none of the containers have been created. I see we are using this something called 𝐶NV, a service type, and the deployment type is kubeserve. Nothing is ready right now. Let's do get all. Take some time for all the containers to spin up. It's still in container creating state. It takes a bit while it's expected. So now 7 have been created, 1 is still pending. Everything is good. Let's run the command kubectl get svc. See, this is the high level object kubeserve svc created, which is running on port number 32160. Let me go to my UI. I think this was the site. Let me put that port number 32160. See, this is V1 port, some object got displayed. That is how I can combine both two high levels at the same time, describe and serve. So now to explain the next topic, let me draw a diagram and try to do justice in explaining this. This is my house. And inside my home, let's say I have a fridge where I kept some bottles, some water bottles, okay? Now I put one more fridge outside my home where again I put some water bottles, okay? So assume this fridge which I kept is outside my home on some roadside or somewhere where I could kept some water bottles for someone people to drink. Now let's say there's an outsider which is not a family member. If he want to get some water, fridge will he access the fridge inside my home or the outside fridge? Obviously the outside fridge, right? This particular guy obviously will go and get the water bottle from the outside fridge I created. Now assume this guy is a family member. Now which fridge should he access to get the water bottle? The outside one or one inside the home? The one inside. So my point here is, let's say you ran an application as some pod, container inside a pod. Now you don't want to this pod to be accessed by the outside people. You only want the pod to be accessed by the internal people, or say people internal to your organization. For that, we use a concept called cluster IP. So using cluster IP, your application is only accessed internally. It is not exposed to the outside world or to the internet. That is the beauty of using cluster IP. Now we are going to see how to use cluster IP in the container. Let me delete everything. So kubectl delete all dash dash all. Let me create a pod. So let's say kubectl run pod one dash dash image httpd. Simply creating a pod. So my pod got created. Cube, let's validate. Kubectl get pods. The pod got created. Now let's expose it. Kubectl expose pod one. I want to expose this pod one, right? And let's give dash dash name, some name, let's say svc1, something, right? Which port number? Port 80. So kubectl get svc. This application svc1 which I created is only internally exposed. It is not exposed to the outsider. So if I do a curl, I can see this being running now. Curl, come on, I did not give the port. Should work there. Here it is. That is how your application got exposed internally. It is something like internet, or you can say whitelist IP, as just now someone mentioned to me. Let's take one more topic, config map. Let's say I want to run a container, a pod, a container inside a pod. And while running a pod, I want to pass some values or specify some data. For that, we use a concept called config map. Using config map, you can supply data to a pod. It's a very advanced concept. Let me show you a YAML file which we can use or which refers this config map thing. This thing you should be able to correlate something called volume mapping, which we discussed in Docker world. Here, creating volume is slightly difficult than what we have in Docker world. You first use something called config map, where you define what value you want to pass. You link some value to it. Let's say a name to that volume config map. Let's say I give 𝐿. Then I link that file to some volumes here. See here, this is the volumes I linked it to it. The file _HTML, I made a volume called HTML from CM. Then I link that volume inside my container and create a volume point that internally map this volume to inside my container USR share nginx HTML. That is how you create a volume mount point using config maps. So let's save this file. Let's create it. So kubectl create -fb.yaml. So now I'm using something called config map. So I will use kubectl get cm. See, a config map got created with the name nginx HTML. Let's see if a pod got created. Kubectl get pods -o wide. So now a pod got created the name cm pod x1. You see that it's using this particular IP so and so running on this so and so machine. So this is how we pass information inside the pod using this particular thing called config maps. It's a very advanced concept. It's like your volume mapping of Docker world. See here, I run this command curl. I got that message, hello config map. One we find passed as a file inside that Kubernetes cluster. You want to find details about your cluster info, kubectl cluster info. I really forgot to show you this command. Your entire Kubernetes cluster information can be found with this command kubectl cluster info. Like where you're running your master, heapster, heap server, metric server, kubedns, everything can be found out in this command kubectl cluster info. The best commands in entire Kubernetes is kubectl get all. Ultimate command. I can use a command called kubectl logs and the name of the resource pod1. If you want to see logs about any Kubernetes resource, you can use kubectl logs and the name of the resource. For example, if you want to see logs about a specific pod, kubectl logs pod1. If you want to find about something service, something anything, svc1, pods only. So let's say second pod, cm-pod/x1. You can find all the logs about it. This is another useful command. If you can say like docker logs, you have something called kubectl logs. So let's talk about one more concept. Let me take an example to understand that concept. We're going to learn a new concept called persistent volume. Let me take an example to explain you the concept called persistent volume in Docker world. So let's say I'm a visitor and I want to check in inside my room in a hotel. Can I directly go and check in inside my hotel? No, right? What I will need to do is I will first need to make a reservation, select the type of room I want to select, make payment, and then only I have to go at this what to say reception, give my ID, and then only I can check into the room. Correct? A simple example. Now take an example. In Kubernetes world, this what are my requirements here? Okay, my requirements are I have to make a reservation, I have to make payment, submit ID, right? These are my requirements. Now, in order to do all these requirements, I need to go at the reception and submit all this. So imagine in Kubernetes world, the type of room we want to select is called as pod. Okay, this is a pod, our hotel, where you want to select a room. Now, all the requirements that we have to given is called, we use a word for this called as PVC, persistent volumes claim. And the person who want to do that, let's call that person as persistent volume. Now, what in short is persistent volume? So let's say you have a pod and inside that pod, you want to do some integration or some mapping here in a more logical way. For that, we use a terminology called persistent volume. We don't interact persistent volume directly with pod. Instead, pod interacts with a component called persistent volume claim, which we call as PVC. And PVC interacts with persistent volume. It's a very advanced concept which we are going to just, I'm going to show an example how to use this in a Kubernetes architecture. So how the things works out, we'll first create persistent volume, which let's say I am the user. So I am the persistent volume. Then we'll create a medium which can interact with it, that is persistent volume claim. And lastly, we'll create a pod which uses this persistent volume. Let me show you how to create a persistent volume. Take a simple example to help you understand persistent volume, what it means here. So let me create a file here. We are using API version, the kind. Here the kind using a persistent volume, another high level object. Here I'm defining some storage capacity to it. You're seeing this 1000 MI. That means this is the storage capacity I'm giving to it. I'm giving the access mode read write ones. There are different access mode, read only, write ones, read ones, read write ones, write ones. I'm giving the access mode as read write ones. Then I'm giving some access policy. I'm giving as recycle. That means if data is not needed, delete it and claim the storage back again. There are different recycle policy available. Trash means if data get deleted, just undo it. Don't give an option to even claim it back. Recycle. So I'm giving a persistent volume reclaim policy as recycle here. Then I'm giving which particular location I want to create this persistent volume. You say persistent volume is like bind mount. I showed you the easier way to create called config map. This is a difficult way to use the same thing. Let's save it. Let me create this kubectl create-f persistent volume.yaml. Let's see if it got created. Kubectl get pb. Now see, my room has been created. Okay, persistent volume. Now I have to make a reservation for this room. For this, I'm going to use persistent volume claim. Right now, my room has been created. Reservation has not been made for this. So now, in order to make a reservation, I will use something called persistent volume claim, something called as PVC, the commonly used industry term. So now let's try to use a PVC called persistent volume claim and let's try to map it to this particular room. Let me create another YAML file, vi.pvc.yaml. Let's save it. Same thing guys here. Here I'm using kind as persistent volume claim. In the previous scenario, I used kind as persistent volume. Dash F is to create, or dash F is dash file name. Which particular file you want to get upon. Now 𝐶TL create dash F is file and the name of your file. So I'm creating a persistent volume claim. What is the name of persistent volume claim? My persistent PVC. Which persistent volume you want to map to it? That means the previous one I create a persistent volume, the name my PV. This is the my persistent volume which I want to map to this persistent volume claim. And let's save this. Let's create this 𝐶TL create dash F pvc.yaml. If you run this command 𝐶TL get pvc, you see the status as pending. Okay, you see the status as bound. Now if you run the command 𝐶TL get pv, here also you see the status as bound. Previously what the status was showing as available, it was not bound. Now you see the status coming bound. That means this room has been now reserved now. So this example, if creating a persistent volume was creating a room, using persistent volume claim, we basically reserve this room. So now this particular room has been reserved with this particular policy called my PVC. See this status here coming as bound. If I run this command 𝐶TL get persistent volume, it is showing as bound. If I run the command 𝐶TL get persistent volume claim, then also it is showing as bound. That means my room is now bound or it has been reserved. Now let's try to tag this persistent volume claim or whatever persistent volume we created to a YAML file or to a pod or to a container. So let's use that and try to tag it to it. So let me create a file called, let's say pi, let's say host.yaml, give some name, whatever you want. See here what we're doing. We're using a persistent volume, giving persistent volume name as PV, claim name my PVC, what we give the name now. We give some name, PVC pod, we give the mount path, whichever volume you want to map to internal PV. Outside this is a complicated way, right? Easier way, I told you already how to do using config map. This is how to do in a complicated way. Multiple ways to do the same thing. We'll use that word. Just save this and let's create it. 𝐶TL create dash F host.yaml. 𝐶TL get pods. Okay, see here it got created. Get pod dash override. Here it is. It's created now. PVC pod one. That is how you link the persistent volume to a pod. Simple example. Thanks.